Okay, we're looking at our introduction to science. We're just going to go through a few of the vocabulary words you should become familiar with just in the beginning here. And let's take a look. Let's see. Okay, the first thing is these two words, qualitative versus quantitative observations. In class, we've talked about the importance of making detailed observations, and in general we can separate them into qualitative and quantitative, and then you'll soon find out which one is more important when it comes to science class and making scientific observations. So qualitative refers to observations where you're kind of just making general statements that aren't really involving any kind of measurements or numbers. So for example, you could have, you know, like a color of something, the type of smell, it smells sour, it smells sweet, it smells stinky, the texture of something, rough, smooth, small sized grains or large sized grains, depending on what you're looking at. Small and large, that's still kind of, you're kind of comparing the difference between the size of something, but you're not giving an exact measurement. So qualitative observations are helpful, but not what we're really looking for in science. This is good in the beginning to describe general patterns, but you're really aiming to make quantitative observations. And I like to remember quantitative because the N in quantitative kind of reminds me of N for numbers. So quantitative versus qualitative. Okay, be careful about that. Try to list a few of your own examples. So any kind of measurements that you're doing would be considered quantitative observations. They're very useful for helping scientists communicate with each other. So examples could be 3.4 centimeters long, 55.65 grams, 4.3 seconds, or any other types of measurements. Kilograms, it could be speeds, how fast something's going in meters per second, miles per hour, or kilometers per hour. And then see if you can pause the video and list a few more examples on your own. Okay, next is a discussion of what's called variables. Now this, we'll spend a lot of time talking about variables in science, but in general, when I asked you all what you understand about science, a lot of you said, well, experiments. Obviously scientists do lots of experiments. Well, how can you set up an experiment to be very useful, to give you a lot of information? Well, it has to be well designed. You have to think carefully about an experiment and to try to find something new out about the world. And in general, we can split variables for now into independent and dependent variables. And I'm going to use an example to try and illustrate this, but we'll use some other examples later. So let's start with my life in 10th grade. Okay, most of this is true. Mr. Lee's life in 10th grade, I had spiky hair, 5 foot 5 inches, I guess that's around 160 something centimeters. Okay, in America I use feet and inches. I know I'm in Japan now and people use meters. I'm still used to saying 5 foot 5. I played guitar. I was pretty good, kinda. I wore jeans that were ripped because that was in fashion, and I did not have a car in 10th grade. Okay, so that's a summary of kind of what I look like. Let's go to 11th grade. Well, I kind of wanted to skip that part, but main point here, no girlfriend. Then we went to 11th grade. Spiky hair, 5 foot 5 inches. I still play guitar, and you know what? I wasn't any better. Exact same thing. The fashion was still the same. Or ripped jeans, and all of a sudden, let's see what changed. Wow, I had a car. Now I know what you're thinking. This is a stupid example. It doesn't matter, but take a look. Okay, then we have a girlfriend all of a sudden. Now if you're looking at all of this and you try to draw some conclusions, it seems kind of silly, obviously, but what kind of conclusions can you draw? You might say, well, maybe he had a girlfriend because he had a car. Okay? And the only reason you can come to that conclusion here is because you can't say it was the hair, because the hair didn't change. The height didn't change. The guitar skills didn't change. The fashion didn't change. So because all these things stayed similar, and only one thing changed, from no car all of a sudden to car, and something happened as a result, well, that's the only reason you could say, well, maybe it was the car that led him to have a girlfriend. It couldn't have been these things because they stayed constant the entire time. So this is a silly example, but this is the illustration of how these things, how these variables kind of make sense. So in other words, if this were an experiment, what did I change? What did I change? I changed this aspect here, having a car, okay, from no car to car. And what happened as a result? Well, from no girlfriend to girlfriend. How do I know it wasn't because of these? Because these stayed the same. These stayed constant. These were controlled. So key, what did I change? The car. That's called the independent variable, what I changed. What depended upon? What depended on whether what I changed, and that's whether or not I had a girlfriend. Okay, let's move on to one more, a more scientific example here. Very simple. Before we even look at that, so this particular student right here is watering a plant, and I could ask a question like, how does the amount of water, how does the volume of water I add to a plant affect how tall it grows? Right? Pretty simple question. How does the amount of water that I add to a plant affect how tall it grows? Well, what am I changing? What am I changing? I'm adding water. I'm changing the amount of water. So I would call that the independent variable. So the variable that is manipulated. Another way to say that would be what do I have direct control over? What do I change? Let me find a pen here. What do I change? I want to write. Okay. What do I have control over in the experiment? What do I change? And that, in this case, it's about pouring the water here. Okay. This variable called a dependent variable, this one depends on what I do. So what's going to change? Well, the plant is going to grow. So in this case, I can say the height of the plant is the dependent variable. And I'm just going to say dv for dependent variable. Well, what do I change? Back again to the independent variable, the volume of water. So I'm going to call the volume of water. That's the independent variable. So in this experiment, where I am asking the question, how does the volume of water, affect the height of the plant? Well, in this case, the independent variable is the volume of water, because I am changing that. And what is a dependent variable? The height of the plant. I can put that in a sentence by saying the height of the plant depends. Remember, D stands for dependent variable. The height of the plant depends on the volume of water. And you're going to see many more examples of this in class. Finally, there's one more type of variable. If I'm doing this experiment and asking this question about how does the volume of water affect the height of the plant, well, if I was setting this up as an experiment, I would want to make sure that if I had two plants, if I'm doing this experiment with two plants, and one's like this and one's like this, and let's say I give this one water, so this one's going to get some water. This is water. I know it doesn't look like, it looks like the plant is screaming. This is water. And this plant, I'm not going to give any water, okay? And, well, what am I going to expect? Well, this plant is probably going to grow. Well, how do I know it wasn't because of the sunlight that this one grew? Well, that's because when I plan this experiment, I'm going to make sure they both get the same amount of sunlight, okay? I'm going to make sure they're both in the same size pot. I'm going to make sure they both get the same amount of fertilizer. And I'm going to make sure they both are the same type of plant. Because in my experiment, I only want to investigate the volume of water. So hopefully you can see that. Pause, think about that for a little bit, and then we'll give you a few more examples. I'll draw another example for you in a moment. So all these things that are staying the same, I'm going to go to the next slide now, and you'll see this. These things that stay the same, that stay the same in the experiment are called controlled variables. So the factors are things in an experiment that you can change. The factors that are kept constant constant, kept constant means you don't change them, to ensure that only the effects of the independent variable are observed are called the controlled variables. Read this to yourself, read the sentence to yourself a few times. You might want to write this in your own words to see what's going on, but controlled variables. Controlled variables. So what's happening in this picture here? What variable are we manipulating? This is the independent variable. Do you know? What am I changing if this is the experiment over here? Okay, what is the dependent variable? What is changing as a result of what I am doing? And which variables must be kept constant if I wanted to do an experiment to really find out about this particular, how this is affecting this. Right? Okay. Let me see if I can give you one more example to think about. Oh, this is black ink here. So if I said puppy, here's a puppy. This is not going to look very good. Oh, that doesn't look like a puppy. Okay. Oh, it looks, okay. Anyways. Oh dear. Okay, puppy, and let's say bones. He's going to eat that. He's going to eat that, and then he's going to run around. He's going to run around, okay? Run around all over the place. He looks, okay, that's how a fly would move around. He's a dog, though. Dog. Okay, what can I change? Okay. He's looking like a cat, dog, mosquito. Anyways, here's my question. I'll write it here. My question is, if I want to find out, if I want to do a silly test or an experiment, I say, how does the number of doggy snacks affect how far my doggy can run? Okay, if that's my question, how does a number of doggy snacks affect how far my doggy can run? Can you identify what the independent variable would be, what the dependent variable would be, and if this were an experiment, what any controlled variables would be if you were going to repeat this with the same dog? I'll leave you with that. See if you can write down some answers, and remember to post a question online on Edmodo. All right, see ya.